Okay, so today we are going to talk about complex numbers, which are essentially imaginary numbers covered in Algebra 2. The standard form of a complex number is a plus bi, where a is your real number and b is the coefficient of the imaginary unit. If you are adding and subtracting as well as multiplying complex numbers, the first thing you want to focus on here in adding and subtracting is basically just combining like terms. Even though I represents the square root of -1, it is still essentially a variable. So here we're going to combine 1 plus 3, which would be 4, and I plus -7i, which would be -6i. This is standard form of your imaginary or complex number, where a is represented by 4, which is the real number, and 6i is the imaginary unit. So in the case of number 2, you would have 4 minus 8, which is -4, and 3i minus -6i, so these two become positive, so this would be plus 9i. Your answer must always be in standard form, which is a plus bi. In the case of 3 and 4, our multiplication, you do need to consider that I squared will be -1, because remember, if I represents the square root of -1, when you square a square root, the radical goes away. So here we distribute 4i, which is 8i. Distribute 4i, this becomes plus 2i squared. We need to simplify I squared by replacing this with -1, which now this has become our real number. So now we have -2 plus 8i, and this is in standard form, a plus bi. In number 4, we're going to FOIL, so this would be 6 minus 8i plus 3i minus 4i squared. Combine your like terms in the middle and replace I squared with -1. 6 minus 5i minus 4 times -1. This now becomes plus 4. And you can combine your two real numbers, leaving me with 10 minus 5i in standard form of a minus bi. What you need to remember are the powers of I that rotate in a pattern of 4. If I represents the square root of -1, remember you will never replace I with the square root of -1. This is what it represents. When you square the square root, you end up with -1. Then this would be I squared times I, which is now -i, and I to the 4th is the same thing as I squared times I squared, which if I squared from up here is -1 times -1, this is 1. This pattern will always repeat in 4s, but one thing you can remember is I won, what did you win? A negative sandwich. So here you have I, -1, -i, and 1. This will always be the pattern, starting with I to the 1st all the way to I to the 4th. So when we simplify any powers of I, you're going to take the power and divide it by 4, because it repeats in a pattern of 4. 4 goes into 54 a total of 13 times. 13 times 4 is 52. We don't care about how many times it goes in. What we care about is the remainder. So when we subtract, we have a remainder of 2. So I to the 54th is equivalent to whatever I squared would be. And when you look above, I squared is -1. That would be your final answer. Your answer for these types of problems must fall between I, -1, -i, and 1. If they have a power, then you have not completely simplified. So in the case here of this, you take 203 and you're going to divide it by 4. 4 goes into 20 5 times. 5 times 4 is 20. Okay? This now has 3. So what you're going to do is take 4 going into 3 0 times, so this is my remainder. This is the same thing as -i cubed, which would be -i times -i times -i. -i times -i is I squared times -i. The value of I squared is -1, which becomes positive I. So -i, the quantity, to the 203rd power is the same thing as positive I. This takes a little work, but you need to remember this pattern up here. Last example like this. 24 divided by 4. goes in evenly 6 times, we have a remainder of 0. So now I to the 24th is the same thing as I to the 0 power. Remember, anything to the 0 power except 0 is equal to 1. Page 9. Complex conjugates. The conjugate of the complex number a plus bi is the number a minus bi. So the conjugate of 3 minus 4i would be 3 plus 4i. This creates a difference of squares. So 3 plus 4i and 3 minus 4i are known as conjugate pairs. The product of conjugate pairs will always be a real number. So if we needed to simplify here this complex rational function, we would need to multiply by the conjugate of the denominator. It is okay if you have an I in the numerator. It's what we can't have in the denominator. And remember, I represents the square root of -1. Therefore, we cannot have a radical in the denominator. So we're going to multiply by 1 minus 2i over 1 minus 2i. You FOIL the numerator. And then in the denominator, this is a difference of squares. So if you recognize that it's a difference of squares, your outer and your inner, which are -2i and +2i, will become 0. So all we have to do is multiply 1 times 1, which is 1, and 2i times -2i, which is -4i squared. In the numerator, we need to simplify by combining like terms and replacing I squared with -1. So we end up with 3 minus 2i minus 8 times -1. And then in the denominator, this would be 1 minus 4 times -1. This becomes plus 8, so we end up with 11 minus 2i. And in the denominator, this becomes 1 plus 4, so now our denominator is 5. Your answer must be written separate because remember, A represents your real number and BI represents the imaginary unit, therefore they are separated. Square roots of negative numbers. We want to write the following as a complex number. When you are multiplying two binomials that have radicals that contain negatives that must be simplified to imaginary units, you must simplify those first before you FOIL. In this case, both of our radicals are perfect squares, so that works to our advantage. This is 7 minus 2i times 5 plus 3i. The I comes from the negative under the radical. The 3 comes from the square root of 9. Now you FOIL. 7 times 5 is 35. My outer is plus 21i. My inner is minus 10i. And my last is minus 6i squared. Again, simplifying and combining like terms, this is 35 plus 11i plus 6, because this is -6 times -1, which now leaves me with 41 plus 11i in standard form. In the case of example B, we do not have perfect squares underneath the radical, but we must still simplify. So the only thing that we can do is simplify by putting an I on the outside to get rid of the negative under the radical. So this is 2 plus I square root of 3 times 1 minus I square root of 7. Now you FOIL. 2 times 1 is 2. My outer is minus 2i square root of 7. My inner is plus I square root of 3. And my last would be minus I squared square root of 21. These are not like terms, so you cannot combine them. This becomes a real number, so it needs to move up front. 2 plus the square root of 21, these are both real, minus 2i square root of 7 plus I square root of 3. This is your final answer.